My name is Paul Goldsmith from the Burmat Applications Division. In this video, we are going to talk about commissioning and maintaining the Burmat PRV two-stage pressure reducing station. This two-stage station is designed to be used where the pressure reduction is significant and the reducing load should be shared by two valves. This ensures high reliability and a safety consideration if one of the valves were to fail. Before we begin, I'd like to present the major components of this station. When the upstream isolation valve is open, water first encounters the main strainer, trapping any debris or foreign objects. The water then enters the primary proportional pressure reducing valve that reduces the pressure by a constant ratio. The water then enters the secondary or pilot operated reducing valve. It is with this valve that we can adjust the downstream pressure to the exact pressure requirement. At this point, if the downstream isolation valve is open, the water will go on to the consumer. Also, in this installation, we have three pressure gauges, upstream and downstream of each pressure reducing valve. Now let me briefly explain how this station works. The primary pressure reducing valve is proportional, and as mentioned before, it reduces the pressure by a given ratio. In this case, we are using a 4-inch valve, so the ratio is 2.5 to 1. So divide the valve inlet pressure by 2.5 to get the valve outlet pressure. For example, if the pressure at the valve inlet is 150 psi or 10 bars, the pressure at the outlet will be approximately 60 psi or 4 bars, depending on the valve size and port trim. Note that this proportional valve cannot be calibrated or adjusted. The secondary pressure reducing valve is located downstream of the primary reducing valve and can be adjusted, unlike the primary valve. It is used to further reduce the pressure to the exact value required. Referring to the example we mentioned previously, where the inlet pressure will be 10 bar, reduced by the primarily proportional reducing valve to 4 bar, we can further reduce the pressure using the secondary reducing valve to any value below 4 bar, let's say 2 bar or 30 psi. So as you can see in this example, by using two pressure reducing valves, we are able to significantly reduce the pressure across the station from 10 bars at the inlet to 2 bars at the outlet, dividing the load with two valves and thereby increasing reliability and service lifetime. Commissioning procedures should be performed when initially opening and operating a station, either for the first time as a new installation or after intrusive system maintenance. Before operating the system for the first time, it is imperative to flush the pipelines. This ensures that the system is free from any debris that can cause damage or even render it inoperable. After flushing, ensure that the main strainer and valve's control loop filters are clean. Next, observe the station's installation and make sure that all parts are firmly secured and in place. Proceed by verifying that the upstream and downstream isolation valves are closed and that you have typical upstream pressure. Now open the ball valves on the secondary pressure reducing valves control trim. Make sure that the service valves on all the pressure gauges are open. Note that the pilot of the secondary valve is calibrated at the factory. You can check the factory level by reading the label on the pilot cover. Before introducing flow into the station, you need to make sure that its preset pressure level is compatible with your downstream pressure requirements. If this is the case, you're fine, and you can leave it as it is. If this is not the case, you'll need to adjust the pilot to the required level. To adjust the pilot, all you need to do at this point is to prepare for it by completely unscrewing the pilot's adjustment screw until it becomes loose. This will cause the secondary valve to close when water is introduced, allowing us to recalibrate from zero pressure to the required value. All right, now slowly, fully open the upstream isolating valve to fill the station with water. Proceed by partially opening the downstream isolating valve. At this stage, if you haven't released the pilot adjustment screw for recalibration, the consumer's line connected to the station will fill in a slow and controlled manner. All you need to do now is to check that the downstream pressure is compatible with your requirements. On the other hand, if you did release the pilot adjustment screw to calibrate the pressure, water won't flow through the station. The reason is that in this case, the secondary pressure reducing valve will have closed shortly after introducing water to the station. Now let's calibrate the downstream pressure to the desired level. Note that the calibration cannot be done without flow. To simulate actual conditions, you should have a typical consumer line open while calibrating, which should give you an average system flow rate. If this is not achievable, then a minimum flow will suffice, though not ideal. Begin the pressure calibration process by slowly turning the pilot adjustment screw clockwise until you hear the valve opening or feel a resistance at the pilot adjustment screw. At this point, the secondary valve will start to open and fill the downstream consumer's pipeline. When the consumer's pipeline is full, continue to slowly turn the adjustment screw clockwise to increase downstream pressure, while monitoring the downstream pressure gauge until you reach the required pressure. To reduce downstream pressure, follow the same process, but in this case, turn the adjustment screw counterclockwise. Once you have reached the desired downstream pressure, close the pilot's adjustment screw locking nut and replace the protective cover. The final stage in the commissioning process, whether or not you performed recalibration, is to remove any residual air from the pressure reducing valves. This ensures a more stable and positive pressure control. To vent air from the secondary valve's control loop, loosen the tube eyebolt attached to the valve cover at the highest point of the valve's control chamber. You may notice air exiting the eyebolt. As soon as you get a flow of water without air, retighten the tube fitting eyebolt. Repeat the same procedure on the primary valve. This completes the commissioning procedure. Now let's discuss maintenance procedures for the Burmad PRV two-stage pressure reducing station. Note that your schedule for preventative maintenance depends on the actual conditions of use and the station's environment. Here we discuss a schedule suited for a valve operating under average conditions. On a weekly basis, perform a visual inspection of the station and check for leaks or external damage. In addition, observe the unit's pressure gauges to make sure that the pressures upstream and downstream are as they should be. Once a year, close both the upstream and downstream isolation valves and clean the main strainer and the valve control loop filter. Every 3 to 5 years, inspect the internal conditions of the pressure reducing valve. Now let's summarize what we covered today. In this video, you learned how to commission and maintain a Burmad PRV two-stage pressure reducing station. You saw how to prepare the station for first-time use and how to calibrate its downstream pressure to meet your specific requirements. We at Burmad hope you find this information useful and invite you to contact us with any questions or issues you encounter. Thanks for watching.